Hello. In this video we're going to be talking about inverse trig functions. Now an inverse function is the inverse of f of x would be equal to y, which is the same as doing f of y equals x. That superscript -1 is not an exponent and doesn't indicate flipping this function to the bottom. Instead, it's a notation for an inverse function. In order for a function to have an inverse, it must be 1-to-1, meaning there's only one x value available for each y value. So our trig functions are not an example of something that has an inverse because they're not 1-to-1. Notice that my value, like a y value of 1, has multiple x values in this graph, both at pi over 2 and -3 pi over 2. And because this thing oscillates out to the right and to the left forever, it's going to have multiple examples of a y value of 1. And so it's not 1-to-1. But if we restrict the domain of this function so that we only go from an x value of -pi over 2 to an x value of +pi over 2, we only have one example of each y value, all the way from -1 up to a +1. So sine, or the inverse of sine equals y, is the equivalent to the sine of y equals x, but this has to include a domain from -1 to 1 and a range anywhere from -pi over 2 to +pi over 2, both things inclusive. So let's practice this. In number 1, we want to find the inverse sine of 1/2. Now, because of what we're talking about, the sine values can only be anywhere from -pi over 2, which is down here, to +pi over 2. So it can only be on the right half of the unit circle. And so we look at sine, my sine values are y's, so where is the y value on that right half equivalent to 1/2? And so here it is. A y value of 1/2 is right there. So an input of 1/2 to my inverse sine would output the angle measure at that value on the unit circle. And my radian measure angle input is pi over 6. So this will be equivalent to pi over 6. In number 2, we're doing the tangent of the arc sine of 1/3. Arc sine is another notation for inverse sine. So to figure this out, we're going to do we're going to make a right triangle, and I'll put my theta here. And so my arc sine of 1/3 would indicate my answer being some theta measure when the opposite is 1 and the hypotenuse is 3. Recall that this is because sine is the same as opposite over hypotenuse. So opposite, my angle measure is 1, the hypotenuse is 3. We can do the Pythagorean theorem to find the missing side length. And so we'll have 1 plus b squared equals 9. B squared must be 8. So b, the missing side length, must be the square root of 8, or 2 times the square root of 2. So if that's 2 root 2, tangent of this angle measure, so tangent of theta, will be opposite over adjacent. And so opposite is 1, adjacent is 2 square root of 2, and that is the ratio for tangent. Now we can simplify this by taking root 2 on top and bottom. So we have root 2 on top, 2 times square root of 2 times square root of 2 makes 2, and so it ends up being square root of 2 over 4. And that's the simplified version of that fraction. So remember, we took that arc sine of 1/3 to be equal to, and that's the output is an angle measure, so we set it equal to theta, and we didn't actually figure out what number theta was. We didn't really care because we're just going to input that into tangent, and so tangent of our theta, and we did opposite over adjacent to find it. So sine isn't the only thing that has an inverse. All of our trig ratios do when we restrict their domains and are able to invert the function. Here are the ranges that our inverse figures are allowed to take. So we talked about arc sine. It can only be between negative pi over 2 and positive pi over 2 inclusive. For arc cosine, it's a little different. For cosine, the function starts at 1 here and then comes down like this before going back up. And so between 0 and pi is when it hits all of its y values. So the range for arc cosine is between 0 and pi. It can only output values between those two radian measures. For arc tangent, its output can only be between negative pi over 2 and pi over 2, similar to sine, but notice that the y's are not allowed to be equal to those values. Arc tangent is undefined at those inputs. So let's talk about a little bit of what we just learned. The inverse cosine of 1/2. Again, I have my unit circle here. For inverse cosine, we're only allowed to go between pi and 0 inclusive, and so that's the top half of the unit circle up there. And so we look for an x value this time of positive 1/2, and it's right here, and the radian measure on that is pi over 3. So the arc cosine or inverse cosine of 1/2 is pi over 3. The arc tangent of 1, tangent has an output of y over x, and so we're looking for a y divided by x that results in 1. That means y must equal x if we're looking for something like that, if this is going to equal 1. And so where does my y equal my x? For arc tangent, if you remember, we can only be on the right side of the circle, and we cannot include pi over 2 and negative pi over 2 as tangent is undefined there. So my x and my y are the exact same right here. The arc tangent of 1 has a radian measure of pi over 4, and so that's the inverse value for arc tangent of 1. Okay, so that's your crash course on inverse trig functions. For now, we are done.